parking available nowadays. I wish there was a way of having an app that easily lets us park whenever we want and book the slots in advance.
Hey everyone, this is Team 51 and we have created an automated vertical car parking system, Park Easy, and we are doing this project under Dr. Vinay Kumar and Dr. Rahul Upadhayay. My name is Aditya Kumar Singh and my roll number is 10180607 and I'm from Electronics and Communication branch.
Hi, I'm Arish Manal and my roll number is 10181511. I am from Electronics and Computer Department.
My name is Kiran, roll number 101815174, Team 51, Park Easy.
Hello everyone, my name is Raghav Sethi and my roll number is 101815068.
Hello everybody, my name is Vanshika Gupta. My roll number is 101815014. I'm from Electronics and Computer branch. Now we'll move on to a small introduction about the project that we've created.
Solution was, so we thought of swapping the traditional toll parking system for an automated car parking scheme where a person is not required for a day-to-day operation. So we do not need any humans for this. This is a completely automated parking system solution. And so we thought that we'll divide this into a few parts. First, we would begin with a vertical car parking system or tower parking in order to increase the capacity of cars over confined spaces, as vertical spaces have no limits. Then a web app to book our slot or the car slot that you need not wait in the queue for. And then there is an automated system, a toll system that recognizes the number plate of your car and it allows you to park. And if there is any technical glitch in the system, it is flexible enough for humans to maintain during its repair and reset. So it covers all the basic parts of an efficient and energetic solution.
Now we'll move on to a demonstration of all the of what we have created. So firstly, we'll be showing you the web application through which you can easily book your slots. So the website is Park Easy and it is built on Django as a backend. And we have used HTML templates for the front end, which are based on Material Kit by CreativeTem. So we've also added a Google Translate system that allows you to change the language into any of your choice so that you can easily navigate and understand what the web page is showing. So we have a register page, which allows the user to enter their details and register themselves on the website. And this has been made using Django authentication. So we have a few already created login ID passwords, which I'll show you. So once you log in, you will be brought to this dashboard wherein you can enter your card details and your time in and time out in the given format. And this will help you book a slot number. So I can set the time I want and on the given date, but in 24-hour format, and the time and date format has been mentioned over here, and I can click on book the slot. So here it shows the slot 1 is booked for me. And since all the slots were empty, I was being given a spot. Now go to the admin panel of this website. So here we can see the users that have registered on the website. And these are the 3 users right now, the bookings that have been made. So here we can see that all the slots have been booked for admin 1 on any given time. And we can check the details of the booking over here from the time to which the slot has been booked. Along with that, we have pre-created 10 slots for test. And as we increase the number of slots for the website, this can be added. And all the users also have their information over here. So we can check the information about the user. The password is encrypted. So even the admin or anybody else cannot access the password. And as it says, the ROS passwords are not stored anywhere, so you cannot see the user's password. Along with that, we can add personal info and we can add if there's super user status or any other things that the admin or any other user has access to. So now moving on, we'll be presenting a little about the ML model that we have created.
For identifying car number plate and its characters, we used OpenCV PyTesseract module, which is trained parameters on huge datasets. First, we capture an image, then we convert it into a grayscale. Then the grayscale image is blurred, and then we detect all the edges and close shapes, and then a rectangular shape is selected, and finally we extracted the license plate information from the image. For blurring the image, we used bilateral filters, and for edge detection, we used Kenny edge detections.
Okay, now let's see the actual steps being implemented in the code, which was previously stated by Aditya. So this is where we import all the modules, and the major modules that were used are PyTesseract and CV2 for image processing. So we had certain steps that needs to be followed, right? Since Aditya mentioned, the first step is to take image. This will in real time be captured by a live camera, which will be in front of the car at the right position so that the number plate is big enough to be captured in the image. And then if I capture the image, and then the next step is we should convert that into a black and white. This step does that, and then we need to blur it so that if there are any certain noises in it, those will be erased and those are kind of removed. And then what we do is we find contours, we find edges followed by contours. We can directly find the closed shapes, but finding after edges makes the task a bit easier and more efficient. We do that. And then what we do is out of all the closed shapes that we have found, we need one that is rectangle and that is the biggest. So this CV2.approx_polydp does that. It finds all the closed shapes and we select the one that has a length of 4, like 4 dimensions, right, for the rectangle. And then if nothing is identified, then we say no counter is detected. And if it is detected, then we'll draw a bounding box. And from that, what we do is since we have shortlisted our area, now we can actually crop it and only concentrate on that particular area and make our task easier. So that's what we do here. These 2 steps are for making that, for masking the exterior area and only cropping the required region. And this is the final step where we use PyTest model. This was actually developed by Google itself. And we have certain parameters here, as you see. So these parameters are actually to tell if what you're actually finding to extract. Are you finding to get only the text or only the numbers or a combination of both? Here, our requirement is both, right? A number will have letters as well as numbers. So that's why we chose 11. I tried with few other numbers, but this is the most efficient one as of now. And when I run this, we get the image. See, this one is detected here. And so this is the actual card number, actual photo which was captured, and this is the number that we have cropped from the pre-processing techniques that we had before. And the observed card number will be printed here. In the real time, this number goes into the backend and sees if this number has already been in the booking list. And if it is, then we'll validate the customer and he can come and place his card. So that's how it happens. These all things can be observed in a short slide, all the 7 steps, from capturing image to extracting the license plate. All these are there in the PPT, which we have presented before. And this is how it happens. Yeah.
So the hardware part is pretty simple. We have a Raspberry Pi connected to a PIR sensor. So when the car approaches the door of the parking lot, so the PIR sensor will sense the car, and the Raspberry Pi will click a picture with its camera module. Now when it clicks the picture, the ML model will run and detect the number of the vehicle, and then it will compare that vehicle number with the database and to check if the vehicle is arriving at the time during which it has booked a slot. And if the number plate as well as the time slot matches, then the door will automatically open.
Thanks to Park Easy, I was able to find a parking spot very easily and efficiently.